Hello, in this part of the lesson we are looking at a two-sided t-test. So the example reads, as at the Hawaii Pineapple Company, managers are interested in the sizes of the pineapples grown in the company's fields. Last year, the mean weight of the pineapples harvested from one large field was 31 ounces. A new irrigation system was installed in this field after the growing season. Managers wonder if this change will affect the mean weight of future pineapples grown in that field. To find out, they select and weigh a random sample of 50 pineapples from this year's crop. The data analysis is summarized below. So our first thing to do is determine whether there are any outliers. So for outliers, recall that we would have an outlier if the maximum is greater than Q3 plus 1.5 times the IQR, or if there is a minimum that is less than Q1 minus 1.5 IQR. And so we need to calculate the IQR, which is the first quartile, the difference between first quartile and second quartile, third quartile, sorry, so Q3 minus Q1, which equals 34.115 minus 29.990, or 4.125. So our lower fence is 29.99 minus 1.5 times 4.125, which becomes 23.8025. The upper fence is 34.115 plus 1.5 times 4.125. So 40.3025. Now our max and our minimum are those two values. And so our max equals 35.547 and our min equals 26.491. And if we compare those to our fences, both values are between the upper and lower fence, so we have no outliers. For part B, do these data suggest that the mean weight of pineapples produced in the field has changed this year? So we're going to do state, plan, do, conclude. The mean is the mean weight of pineapples in the field. Our null hypothesis is that the mean is 31 ounces, and our alternative hypothesis is that the mean is not 31 ounces. And that comes back to, do the data suggest that the mean weight has changed? So we're not saying whether it's gotten bigger or smaller, right? And we will be using alpha equals 0.05 as a standard, since the significance level was not stated. All right, plan. If conditions are met, we will do a one sample t-test. For mu with, think about how many degrees of freedom. If we have 50 samples, 50 pineapples sampled, so we have 49 degrees of freedom. So we also need to test conditions. So check for random. It's stated that pineapples came from an SRS. Independent. We are sampling without replacement. But it's safe to assume there are more than 500 pineapples in a large field. So therefore the 10% condition is met. Okay, and finally normal. We don't know about the underlying population. But the CLT, central limit theorem, tells us the sampling distribution is approximately normal if n is greater than 30, greater than or equal to 30. So this is satisfied. Because n is equal to 50. So finally, do. We were given x bar equals 31.935, and the sample deviation, standard deviation is 2.394, and so we will use our calculator, and we're using the t-test. So use the t-test, we go stats, tests, and number 2 is the t-test. We will choose stats. Our mean, our null hypothesis mean is 31. I've entered in x bar and sx, so the sample standard deviation, n is 50. Our alternative hypothesis is that the mean is not equal to the null hypothesis mean of 31. And so first we will calculate. Oops, sorry. So calculate that. And from here we get t equals 2.7616 and p equals 0.008. We'll round that to 0.0081. And they give us again the data that we entered in. So we will enter that in. So as you can see, I've taken that information and I've entered it here, t equals 2.79, p-value is there. So to conclude, The p-value of 0.0081 is less than the significance level is less than the significance level of 0.05. So we reject the null hypothesis and conclude there is more convincing evidence that the mean weight of pineapples in the irrigation field is not 31 ounces. Okay, so that's our answer to part B. In part C, we were asked, can we conclude that the new irrigation system caused a change in the mean weight of the pineapples produced? Now, this was not a controlled experiment. We only had the pineapples being watered. We did not have a matched field where they were not being irrigated. And there might have been other factors in this year, so we can't compare it to last year's crop either. So since this was not a controlled experiment, we cannot conclude that a difference in pineapple weight was due to the irrigation system. Other factors, such as a warmer growing season perhaps, e.g. a warmer growing season, could have affected pineapple weight. Okay.